ahead and get started here. So today, do you remember at the end of class we do have a quiz, but before that I want to review a couple things about printing and reading numbers from the user, or I should say reading data, not necessarily specifically numbers. We're going to talk about the const keyword, modulus operator, random numbers. Talk about ASCII values if we have time. I don't know if we're going to get there or not, but we'll see. And then finally, at the end of class, we're going to have a quiz. And we're also going to work on an in-class assignment. So we got a lot on the agenda today. Like that. So, any questions? So this is the last opportunity you'll have to ask any questions before the quiz. Is there anything that you guys don't understand right now that I can help you out with? Assignment 2 going all right? Okay. So, just going to review printing and reading quick, and then review what we mean when we say expressions. So, just remember we can print out numbers, or we can print data by using printf. When we specify a format identifier inside our format string here, it will search ahead in our comma-separated list of parameters, and it will replace the first format identifier it meets with the variable or literal that's said here. You can also put an expression here like we talked about on Tuesday. So I could say 10 plus 20, and that would substitute the value for f of the result of this expression. So remember that our basic format identifiers for printf are %i or %d, as the text would say, for an integer. So that's an int. And then it would be %f to print a decimal number. So a double, as we would say. That's the type. And then finally, the last one we talked about was character, and that's to print a character. It's an isobel character. Or char is the data type in C. So those are the different format identifiers we can use. Just keep that in mind. So again, when you see this \n, what's going to happen is it's going to print a new line. So I just want to do one example here. So let's say we had a printf comprised entirely of new lines. We could put more than one new line inside our printf. So just put a bunch of them like that. We can put as many as we want. We can put text in between them. We can put format identifiers in between them. But again, wherever we see a new line, a \n, it's going to print a new line. So we have 1. So from 1 to go from here to here. So that's 1. Then 2. Then 3. Then 4. Then 5. And then 6 to get down here. So that should have been 6 new lines if I counted correctly. 1, 2, 3, 4, 5. So I was off by 1, but it was close. So yeah, that's that. So remember, for when we're writing a scanf, to scan into a number, we say scanf, a format identifier, and an ampersand, and a variable name. So in contrast to printf, remember that scanf can only read into variables. Obviously, you can't say something like this with the scanf. You can't read into the number 20, because that would change the value of the number 20, and obviously we can't do something like that. So again, you say an ampersand and a variable name. Now remember, that variable has to have been declared before. If we say something like an ampersand my var, that variable hasn't been declared before. What's going to happen is when we go to compile that program, it's going to say error my var undeclared. So you need to declare the variables before you use them, remember. So you say the data type my var. You could optionally give it a value if you so choose, but you don't have to. So remember, we have all those warnings because we didn't use any of those variables. For now, we can just ignore that. But I guess that program didn't even do anything, so that's fine. So just remember an ampersand and the variable name. So in contrast to printf, if I was to put something in here, if I were to say ASDF, when I ran this program, I'll write a printf to output my var really quick. run that. So that scanf didn't work at all. So when we put things in scanf, it's going to try and read in these actual values before it reads in this number. Same thing that happens, well, it's actually kind of different when we put a new line at the end of our scanf. What's going to happen is it's going to try and read in an integer into my variable, and it's either going to read in the new line into my var as well, or it's going to wait for you to push enter again, which is, it depends on which platform you're on. So that was the review of printf and scanf. So just remember that when we're declaring a variable or we're assigning a variable, just remember the basic formula for that is you say the variable name on the left, an equal sign, and then an expression on the right. And remember that an expression can be comprised of any of the following. So expression is a variable, a literal, or an operator. So the only thing is you obviously have to have an operator in between variables or other literals. You can't say something like this. You can't say a equals plus. That doesn't make any sense, obviously. You need to say, and you couldn't say something like this. You'd have to say, obviously, a plus 20 or something like that. And remember that you can chain as many operators, variables and literals together as you want to, and you can control precedence with parentheses. So if I had something like this, where I was doing that, and I wanted this addition to be done first, you could put parentheses around that to enforce order of operations. So that's all I had for review. Any lingering questions about that? All right. So a new thing we're going to talk about today. I realized that I probably should have assigned the chapter 2 reading for today instead of for Tuesday, because I ran out of material to actually cover for this week. So I'm just going to go ahead and cover a couple things in chapter 2 that we haven't covered yet. So the first thing is the const type. So we can put consts in front of variables whose value we want, or whose value will never change. So normally what we would say, let's say we had our int a here. Let's bring our program all the way down to here. So we have int a. So let's say that variable contains a value that will never change. So what we would typically want to do is say const int a. So what that instructs the compiler to do is if it sees you trying to change the value of a, let's try and change the value of a. Let's change it to 30. And then try and compile our program. What's going to say is error assignment of read-only variable. So when we say const, that means that our variable isn't going to be able to be modified later. So what that allows us to do is write programs. It really helps us remove the errors from our program. So let's say we had a constant value. Let's say we had a equal to 20, then we had b, and let's set that equal to 30. And somehow we accidentally managed to, instead of saying b, let's say we want to set b equal to 50 or something like that. Instead of that, we accidentally typed a. If we had typed const in front of here, and we had made that mistake, what would have happened, of course, with the compiler, would have been the compiler would warn us that we're trying to change that variable. So by typing const, it's just another defense mechanism against changing variables that you don't want, or you don't want modified. So it's another thing that allows you to write programs that are easy to solve errors in. Because when you're starting to write bigger programs and you see maybe it happens where your entire compiler output, you have an entire screen full of errors, it does get to be tricky to find where those bugs are happening. But if you're assigning const, you're specifying the const keyword when you're declaring something that you don't want to change. It just adds more specific errors when you're running your program. So in addition to just saying const, we also want to generally make variable names that are constant all uppercase to be readable as constants. So normally when you're looking through code, regardless of the language, not necessarily limited to C, when you see something in all uppercase letters, that's generally an indicator that it's a constant variable, that its type was assigned as soon as it was declared, and that it hasn't been modified since. So let's think in terms of our tax program. Let's say const int, well, we'll just say double tax rate. Let's say our tax rate was always 0.7% and we never wanted it to change. So instead of just saying this, we would say, and then whenever we see this in our code, let's say we also have another, that's not const, this is const. Let's say I'll just assign the input to be 10 right now. Let's say when we're doing our calculation, input times tax rate, we can see that this is clearly a value that's never going to change. And even if we don't specifically, even if we have code that's going down the entire page, we can always see that variables in all uppercase, separated their words by underscores, are constant, even though we can't necessarily see it right then. So that's constant variables. Any questions about that? We'll come back to this more later when we have more complicated programs that we're working on. So the next thing I want to talk about is the modulus operator. So when we're dividing two integers, remember that any remainder is discarded. So let's say we take 20 and divide it by 9. Remember that results in something like 2.2, but that remainder is dropped unless we cast one of the sides to be a double. So one of the things we can do is when we're dividing integers, we can actually get the remainder as a whole number, as an integer itself. So let's do some examples here. Let's say int A, int B. We'll do the 20 and 9 again. So we will say div result and then remainder. And then I'm just going to write an expression right inside here to actually do that calculation. So instead of having an intermediary variable, I'm just going to write it right there. You could also do something like int res equals a times b, and then use that variable name here. But remember that inside our printf, we can also write an expression, and inside that expression, we can have any combination of variables, literals, and operators. So in order to get the remainder, we use the modulus operator. So I say a, and then the percent sign, and then b. So this is referred to as a mod b, or this operator, again, is either called the modulus operator, some people just call it percent sign, so on and so forth. So running this program, we should see a remainder of 2, I think. Did I run the wrong program? Or did I not compile it? I put rex. Excellent. Good catch. That's not it still. It's res, not rec. So I probably multiplied, didn't I? Classic case of not knowing what's going on at all. Yeah, so we can see that dividing 20 by 9 would give us a whole number result, or a whole number division result of 2. But we can also check what the remainder of that division operation would be too, using mod. So just showing you this again, I'm going to go and change this to be from that expression like it is to say a mod b. So we'll just take out that inline expression and replace it with a variable. Just want to show you that that still works. So let's change this. Let's change our number to be something a little bit different. Let's just see how none of the numbers change. So we'll change that down to be 8. So we can see that there was obviously still 2 8s in 20, but the remainder of that division operation was 4. So there's kind of two different ways you could go about doing division in C. You could always use floating point numbers, or you could divide it and store the remainder. Now, more often than not, mod is used for a lot of other different math operations in C. Most of the time, we don't really specifically care about remainder, but it is powerful for a lot of other things, like the things that I'll talk about next. So here's some examples. So 10 divided by 2 would result in 5, and that is what do I say? What's the term? What's the term when the division doesn't result in a remainder? Well, it doesn't result in a remainder. So the result from 10 mod 2 is 0. So there's no remainder from that operation. Then if we took 10 divided by 3, there'd be 3 3s in 10, but there'd also be an additional 1 as a remainder, and so on and so forth. So that is modulus. Any questions about that? Okay. So then, I think this is going to be the last thing I do today. I think I'll put off doing ASCII until next Tuesday. So, one of the things that we can do in our C program is generate random numbers. So we can do that with something called a pseudo-random number generator. So that's an algorithm for generating a sequence of numbers whose properties approximate the properties of sequences of random numbers. Now, in order to get truly random numbers, what we'd have to do is essentially have sensors that detect electromagnetic interference in the atmosphere, because that's the only thing that we can really know to be random. So when we think of really random numbers in computer science, we think of numbers that don't really originate from the computer. They originate either as a byproduct of operations, a kind of electrical noise that the computer generates, or electrical noise that originated from other sources. So that's really complicated stuff, but for right now, what we can do is use the C pseudo-random number generator to generate numbers. So, in general, a pseudo-random number generator needs a seed state, a number to start calculating other numbers at. So when we're generating random numbers in C, think about it like this. We're just going to, well, here, I'll open this up. We're just going to start at a random number. So we're going to pick a start point. Let's say we're going to start at 60. So what our random number generator is going to do is every time we try to acquire a random number, it's going to do an operation on that start point. So let's just rename that to be something A. So let's say every time we try and get a random number, we're going to say return. So sorry. So we'll just set a. We'll just say A as our output. So we're going to take the old A, and let's say we're going to times it by 100, divide it by 70, add 50. I don't know, do a bunch of different math operations that will result in a number that's significantly different from where we started. So what's also going to happen when we're doing this is we're going to set our state in our random number generator to be this new number that we generate. So every time we acquire a random number generator, we're going to get a random number, and we're going to save the state of where we're at in our random number generator. So every number that we should get should be essentially random. It will look random. The only difference between true randomness and this is, given this seed value, as we would call it, I can predict where that what number is going to be generated next, given this algorithm. So when we start at 60 and we generate, let's say our seed state is 60, and we start generating random numbers, what's going to happen is every single time we run our code, that number is always going to be the same. Or the sequence of numbers that are generated are always going to be the same, I should say. Now, one of the things we can do is set our seed state equal to time. So there's a function called time in C, which returns an integer describing the current time. And if we want mildly random results, we can just set our seed state in our random number generator equal to the time. So going back over here, so again, it will always produce the same sequence when initialized with a specific number. So when we are doing random numbers in C, we need to include a couple new things on the top of our C programs. So we say include stdlib.h and include time.h. So the first thing we need to do in our program is when we're using the random number generator is we need to say srand like this, so srand, and then parentheses. And then our seed number that our random number generator starts at goes inside this srand. So let's just say for now we're going to use that 60, and we're going to always start at the number 60. So every time we want to get a random number, all we say is rand, and that will return a random number. So this expression right here will return a random number. We can use, this is what we would call a function call, and we can use that any other place that a variable or literal is expected. So going back to what we mean by expression, so expression now is, it's now not only a literal, an operator, and a variable, it is now also a function call. So we've added things like rand. So when we say rand, that will be replaced. Think of this, if we have this expression, say we have int a, and then a equals rand, this right here will be replaced by a random number. So if we included that in other expressions, let's say we started out and we wanted to add a random number to a, let's say we started out at 0, we could say is a plus random number. And that would result in a random number being substituted here, and of course the value stored in a, which is 0, being substituted here. So that might look something like a. Once being processed, it wouldn't actually look like this in your source code, but when it's being processed, this is what it would end up looking like. So you could say something like, that a would obviously be substituted for 0, and let's say our random number is that. That's our random number that was generated. Now it's worth noting, going back here, that the random number results that we receive will be between, what's that, 2 billion and negative 2 billion? Something along those lines. So we need to modify, use the mod operator to change the numbers that are actually retrieved from our random function call. So these are a couple of examples. So what happens is, this is obviously replaced with the random number. It could be any number in between this range. And then when we divide it by 100, we get the remainder from that operation. So the remainder from dividing by 100 can only be between 0 and 99. So let's just go ahead and do some examples. So let's just say I'm going to declare a variable int res. We'll say res equals rand mod 100. So when we say mod 100, that will give us results 0 through 99. Again, what we're doing is we're taking the result from our random, from our rand call and dividing it by 100 and getting the remainder. And remember that the remainder can only be between 0 and 99. And then we're going to print off that. So we got 5. So remember that if we initialized our random number to a literal number, whenever we run this program, it's always going to be the same. So even though we're saying random, it's always going to generate the same sequence of numbers since it's a pseudo-random number generator. So let's say we just copied this code. We're going to run it a few more times. We'll just run it 2 more times, and then we'll call it good. So we can see that if we only ran this once, those look like random numbers that would be generated between 0 and 99. And if we only run it once, it does look random, sort of. Again, we run it again, we're going to get the same sequence of numbers. So opening up our source code again, we can change that 60. Let's say we want to start out at 10,000. 10,000. So when we start out at 10,000, we do get slightly different results, but just keep in mind that they are always the same results. So when you're writing programs that utilize random numbers, something that's usually good to do is when you're writing your program for the first time, when you're writing the logic for the first time, put a number that won't change in here, put a literal number in here, so you can see that the values that are being generated, and you can kind of prove the results that you're getting from your program. So once we've done that, what we can do is print using the time. So what I'm going to do really quick here is to show you what the time function returns. So we'll just print f %i for our integer, and then we'll call time with a parameter of 0. So this will be replaced by an integer describing the current time again. And I'll ignore that for right now. So we can see that this integer is incremented every single second. So running it over and over and over again, we get an integer one bigger every single second. So we can see that basically every single time we run our program, unless we're running it really, really fast, we're always going to start at a different point. So going back, I can change this. And what I can do, remember that since our list of things that we can use is now expanded to, say, a function call, so we can actually specify a function to call right inside here. And the result that's returned from that function call will be used as a parameter to the next function call. So let's see what I did wrong here. There are too many arguments. So I said rand when I actually meant to say time. So remember that rand doesn't take any parameters, so that was the error that we were getting there. So it said too many arguments to function rand. So the C compiler will tell you if you're trying to use a function incorrectly, if you're passing the wrong type of data to a function, and if you're passing the wrong number of arguments, and a number of other different things. But I changed that. I changed it so remember, this is going to return an integer describing the current time, and it's going to immediately pass it to srand to seed the random number generator. So we can see now that whenever we run our program, we do actually get sort of random results. And as long as we're not using a million of these numbers, they'll be pretty much random. For our purposes in this class, these are random numbers, and that's what we can do. So just remember, if I do, see right there, I ran it fast enough, so that integer that describes the time didn't increment another time. So if I do run it really fast, I'm going to get the same results. So that's why we need sort of a better source of randomness in more high-performance computing environments. So yeah, I think that's random numbers. And that's all I had for that. Any questions about random numbers right now? Yep. Yep, right here, we just need an expression. So anything that is an expression can be put here. So again, we could say 10 plus 10. That's completely valid. It's going to get the result of this expression and pass to the function. Again, you could absolutely do that. You could say int a equals 100 and then pass it in there. So again, any valid expression can go in between these parentheses. Now, the only thing for srand is we can only pass in an integer. So if we did something like this, we said double A, type double A, and we try and pass that in. It's going to work because I don't know what's going on. I guess it's going to take a double 2. Theoretically, it shouldn't, but it does anyway. So, using other functions, we would not expect that to work. Let's try and call time. We'll call time and pass an A. I'll try and find something where this doesn't work. Yeah, so here's what it says. So this is what I thought it should say for sran, but it's saying it for this one now. So it says error incompatible type for argument 1 of time. So this function, it's just saying that one does expect an integer. So if we change this to be an integer, pushing the wrong buttons again, and it fails for different reasons. But that's not important. So yes, you can use a variable. So that's the long rant. We good with this then? All right, so what we're going to do now is start the quiz. So I'm going to skip over asking until Monday. So with the quiz, it's going to be quiz 1 on D2L. You'll have 15 minutes to complete the quiz. So the quiz is closed book. You can only have D2L open until you complete the quiz. And then when you are done with the quiz, I'd like you to work on the in-class assignment. So the in-class assignment for today is create a program which reads in a number from the user, and then it generates and prints a random number between 0 and that number. For right now, if you want to seed your random number generator to a literal number, that's fine if you want to. I don't really care for the assignment. I just want you to get a little bit of experience working with rand. What I will do is bring back up the source code that I was working on over here once people have started the quiz and once I've seen most people have finished it. So I'll probably bring that up at about 150 or so. So for the quiz itself, do remember that you have 15 minutes to complete the quiz, and the quiz is completely closed book, so I expect to see nothing but D2L on your screen. And the password is \n, so you should be able to start that up. Okay, sorry. Classic case of not knowing what's going on.